Welcome to Ask and Learn.
Okay, the graph of function g is shown, which I've drawn, and we were being asked to verify if this function satisfies the hypothesis of mean value theorem, estimate the values of c that satisfy the conclusion of the mean value theorem, and estimate the values of c that satisfy the mean value theorem in a different interval, so from 2 to 6. So let's begin with some of the conditions that are required for the mean value theorem. So there are two big conditions that are required for the mean value theorem. Is that so this function g has to be continuous. So continuous on the closed interval, on whatever interval it is. In this case, it is 0 to 8. And differentiable. And the second condition is differentiability. So it means it is differentiable. You can take the derivative at any point on the open interval from 0 to 8. So if we look at this function, we know it's continuous because we can draw this function without picking up our pencil. And you can see that there's no holes or any sort of, weird things that are happening. And so that means that this satisfies the hypothesis for mean value theorem. So what is the actual conclusion for the mean value theorem? Before we answer this question, we need to know what is the actual conclusion. And so the conclusion actually is that there would be a number c such that f prime of c is equal to f of b, which in this case is f of 8. So f of 8 minus f of 0 all over 8 minus 0. So essentially what this means is that the average slope from 0 to 8, so the slope literally from 0 to 8, so if I draw this line right here, try to draw a straight line. So this slope right here from 0 to 8, there's some number on this interval such that the tangent, so there's a number c, so some number along this x-axis, such that the tangent on this, the derivative or the tangent line on this curve will be the exact same slope, not necessarily the exact same line, so it'll be parallel to the to this slope. So how do we find this value? So we can do this. Well, first we need to find the slope. What is the slope of this line? But the slope of this line is, so if we look at this value, f of 8 is 4 and f of 0 is 1. So this will be it'll be 4 minus 1. So 4 minus 1 over 8 minus 0, which is 8, and then this becomes 3/8. So that is the slope of this line. So what is this? So what are the values of c that satisfies this conclusion? Well, since we're being asked to estimate the values, we can simply just look, visually at where this is happening. And if we look at this point right here, this point right here looks really similar to this line. The slope at least does. And this is a little less than, that is the very, very, very bad line. But if you look down this way, it is about 2.8. So we can say this one is 2.8. But we're not done yet, actually. This conclusion tells us that there is for sure at least one value of c that exists. And if you look closely, there's actually another one. 3, 4, 5, 6. If you look at this point right here, it's a little hard to tell on this graph because it wasn't drawn as neatly, but you can see that this is also parallel to the slope. So there's another value in my graph. It looks like it is exactly at 6. 3, 4, 5, 6. It may be a little bit around 6 in the actual graph, but it should be near a value of 6. But you can see that this is essentially what you're looking for is parallel slope. So this tells us the answer to this. All right, now I'm gonna go back, clean up this graph a little. So the second question is asking us to find the to satisfy the conclusion in a different interval from 2 to 6. So from 2 to 6 is right here. So this point and 3, 4, 5, 6, and this point. And this slope right here. So we're looking for a slope like, okay, we're looking for this slope right here, this average slope. And we can calculate this value. So at this point, f prime of c, though f of 6 is approximately 1. It'll be 1 minus, and then f of 2 is approximately 3. It'll be 1 minus 3, and then it'll be all over 6 minus 2, because that's how you do it. And then this gives us negative 2/4, which is really just negative 1/2. So that is the slope of this line, negative 1/2. So now we're looking for a c that kind of looks like the slope. Since we're being asked to estimate it, we don't have to find the exact value of c. So here you could see that this value right here, this tangent, looks very similar to this. It is parallel to the slope. So this value is around a little greater than 3. We could say 3.5. And then our next value is, you could see another one right here, right at this tangent. So if you take a line and go through right here, this also looks very similar to our average slope, and that is around 5.5. So there you go. Those are our two values that satisfy the mean value theorem. Thank you.